Before we get started, I want to tell you about my new book. It's called The New Mobility Handbook, Rethinking How We Get Around Cities. The book builds on my work on the Smarter Cars podcast here over the last 3 years as we've explored autonomous vehicles, ride-hail, and then micromobility, and the impact of all of these new technologies on cities. New mobility options are incredibly popular and can encourage multimodal travel in ways that public transit has not. But these options have also created new challenges for cities that can't be solved by technology alone. We need to combine these new mobility modes with urbanist policies to keep our roads moving. Transportation in cities will not be an either-or solution. We don't have to choose between ride services, bikes and scooters, or getting everyone to ride the bus. It's not either or, it's and. We're going to need all of these technologies working together to rethink how we get around cities. The New Mobility Handbook offers a grand unifying theory of sorts for how we can have the benefits and convenience of new mobility options while also meeting city goals to encourage multimodal travel and reduce traffic and pollution. If you're not familiar with the principles behind urbanist policies like congestion pricing, transit priority, reduction in parking, and reallocation of street space, the New Mobility Handbook provides an introduction to these policies and how they can be used together with new mobility technologies to improve transportation in cities. The New Mobility Handbook is available on Amazon in paperback and Kindle versions. I hope you enjoy the book. This is Smarter Cars, a podcast about autonomous vehicles and the future of transportation. Welcome to Season 5. This is your host, Michelle Kairouz. In this episode, we're talking with James Wu, CEO and co-founder of DeepMap, a company that makes HD maps for autonomous vehicles and for ADAS systems. James, welcome to the show.
Thank you for having me.
Can you start by telling us what DeepMap does and a little bit about the origin story of why you started the company?
Sure. DeepMap is a company we started 4 years ago. And what we do is we build a HD map engine. And we use this engine to make customized HD maps for the self-driving car industry, our customers and partners, so that they don't need to reinvent wheels. They can scale with us. They can reduce the cost of making HD maps and maintain the HD map. We also reduce our customers' risk in terms of using our technology because we build very high quality HD maps.
And why was this a problem that you wanted to solve?
So it's kind of interest, right? Before I started DeepMap, I was a principal architect for working for a self-driving car company. And at the same time, I got a lot of invite from many other self-driving car companies asking me to join them and help them build HD maps. Then I realized there's a common need in the industry that the self-driving car make a very specific HD map that works very well with the self-driving car software and hardware sensor kits. So that's where I realized there's a big challenge in the whole self-driving car industry because there are many players in the industry, but there's limited amount of talent who can build this kind of a high precision map. And also I see there's a huge amount of reinvent wheels across the industry. What will make things even worse down the road is actually when the self-driving car company try to scale and deploy a huge fleet of self-driving cars in a lot of places geospatially, the mapping part will become a very challenging problem from a technical perspective and a cost perspective. Technical perspective, scaling a centimeter level precision HD map is very, very difficult. And it will be super expensive to make the map and maintain the map.
Right.
This is actually from my background working for many other map companies. I used to work for Google Earth, Google Maps, and I also helped Apple launch their map product. And I worked for another five map companies in my career. So I know too much mapping. Mapping is actually a pretty expensive operation for all this. And what makes things even worse is HD map. We're talking about centimeter level precisions, right? When we have very high precision maps, it will capture tiny changes in the environment as well.
Tell us a little more about high definition or HD maps. How are they different from a regular Google map? And then can you take us through the process of how you create an HD map?
Sure. The HD map, the main difference, let's put it simply, is that a HD map is a map for a machine or for machines. Well, maps like Google Map and other map suppliers, Apple Map, most of their usage is for human being, right? Driver or ride sharing, this kind of applications, navigation. So I think that's a main difference. While for the HD map, because of it's used for a machine, the precision of the map is quite different. And also the content of the map will be different. For a navigation map, you probably need to know where the coffee shop is. For a machine map, it's different requirement. You probably need a lane level association with traffic lights and signs, this kind of things.
And is that because humans bring to the map their own knowledge of how the world works? Like, you should stay in a lane and there's a curb over there and this is what a left-hand turn lane means. Is that because the humans already bring that to the problem? They don't need that in a Google map, but an autonomous vehicle sort of needs that specificity?
How do I say this? So I think for the machine map and human map, there's some common things. The common part is for the human map, it is also a prior knowledge of the environment, right? Before you go to a new place, if you have a map there, it make you feel familiar with the environment and helps you navigate in that environment. So today, if you're traveling, it's very, very difficult if you can't have a mobile map, especially when you go to a new place. For the machine map, in the sense of prior knowledge of the environment, it is similar, right? So if a self-driving car navigate a certain place that it has never been there before, it will make the self-driving task, navigation and control, more difficult, have higher risks. Well, if you can have a prior knowledge of the environment, it will make the car drive safer and have lower chance of having issues.
Right. So take us through the process. How do you create an HD map? I think about the Google Street View cars we used to see driving around. Do you have a set of map data collection cars, or how is it that you start your process to create an HD map?
So this is a very good question, right? So because it's a machine map and it's also a prior knowledge of the environment, so the map itself is heavily depend on what kind of sensors the machine is using to observe the environment, right?
So you need the same type of data collection that the autonomous vehicle is going to use when it uses your map?
Yes. So that's why we're building a HD map engine where we enable our customers to use their self-driving cars to build the map and use their self-driving cars, update the map. And we just enable them to do this. This is our ideal situation for the self-driving car industry.
So you don't go out and collect data or drive around. You rely on your customer's autonomous vehicle test fleet, and then you take their data and run it through your map engine to create the map?
Yes and no, right? So for some of our customers, we're doing that. For certain cases, we do some kind of bootstrapping approach as well. So during the years, we develop our own mapping rig, We have a very simple mapping rig using both camera, LiDAR, GPS, IMU, and a bunch of other sensors. It's fairly cheap, and we can use this kind of rig to simulate a mini self-driving car. It's not really a self-driving car sensor kit, but the sensor can actually simulate or quite approximate the sensors a self-driving car use. And we can use this kind of rig to quickly and easily map a certain region before our customer deploy their self-driving cars.
It's kind of a chicken and egg problem. How do you get the map before you've driven it? But I assume they drive it not in autonomous mode in order to originally collect the data. So what does your map engine do then? I assume the data, pixels or voxels or whatever the data is that comes in, how do you take that data and render it into an HD map? I've seen what it looks like, and it kind of looks like a LiDAR point cloud married to basic video. Is it similar to how virtual worlds or games are rendered from a software or technology perspective?
There's some similarities. So in order to make this very high precision map, there's a couple of steps we need to do. The first step is we need to make sure all the sensors are very well calibrated, spatially and geometrically. And the other part is we need to synchronize all the sensors very precisely. So once the sensors are very well calibrated, then we can collect data high quality data that can be used. And this also has two ways. If we're using our own mapping rig, we can actually, it's already pre-calibrated. It's already generated very high quality data. Well, if we're working with our customers, we need to make sure actually our customers' sensors are very well calibrated as well. We do both. Once we have the sensor calibrated, then we collect data using the sensors, driving around the region that we need to map. Then we create a digital clone in 3D of that environment. It's like 5 centimeter voxels representing the whole environment. Of course, we can configure the size of the voxels, but based on our experience, 5 centimeters is good enough for the precision and the safety requirement. And within this 3D representation, digital clone of the environment, we can derive more information, use machine learning to extract the semantic meanings like traffic light, signs, lanes, all this, we call it vector layer or landmark layer. And we use this landmark layers to guide the self-driving car. The voxel layer can be also used to help the self-driving car to do localization and also to understand the environment, figure out what has changed in the environment, and find out the obstacles as well.
So take me through again then the layers of an HD map. There's sort of a base map, which is what humans would think of as a Google map, and then you're using the data, the voxels, to create a geometric, more three-dimensional map. And then you mentioned this semantic layer that's more of an understanding of things like stoplights or speed limits, things like that. Can you explain what the different layers are?
Sure. So we can start from scratch, right? We don't need airborne imagery, a satellite imagery. We don't even need a base map. Okay. We can go to anywhere that the customer want to test their self-driving cars, including underground or in a parking structure or in a parking lot or in a highway or urban, anywhere. Then the base map is a 3D reconstruction of the environment. That's our base map. We call it OMAP. And based on that, it's because it's a digital copy of the environment, we can derive the semantic layer, which is a vector layer. All the lanes, signs, traffic lights, their relationships, this kind of information.
And then you mentioned using deep learning. I'm assuming that's some computer vision to understand that there's a stop sign or a traffic light or a left-hand turn lane. Do you then use a layer of human work to go through and make sure that it's correct or that it's properly addressing the semantic layer?
Yes, we actually have a very high standard on map completeness and the map correctness because it's very, very critical. If you make a mistake in your map layer, the consequence can be very bad. So we do have humans in the QA loop to make sure everything is correct. Beside these two layers, we actually can add more layers in the map. Beside the base layer, the geometry reconstruction of the environment, and the semantic, we can add customer layers for their localization algorithm. We can add customer features to help our customers planning and routing and building the horizon. We can do a lot of customizations. So it's not a fixed map. It can have multiple layers. And
Right.
we're going to do QA for all of them.
So, how often do HD maps change, and how would you learn about those changes? Like, if an autonomous vehicle drives down the street and it sees something different from what the map says, maybe a stop sign has been replaced with a flower pot roundabout. Does that information get stored on the car as a discrepancy? Is it transmitted back to DeepMap? How do your HD maps change over time?
So the key requirement for HD map to be useful is freshness because you have so if you have like a 5 mile road, it seems always the same. There's not much change. But if you look at the centimeter level and you have like 5,000 miles of map, there's change all the time, all over the place. So when you scale and when you use the self-driving car system, you need to understand the environment change. You need to understand if the sign has changed, the lane has been repainted, if there's new obstacles, road blockers. And sometimes you want to know this as soon as possible, right? When any changes happen. So the key property of HD map is actually not map creation, it's map update and map maintenance. How fast you can update the map and how frequent can you capture the changes in the environment. That's why actually when we start a company, we focus on this map update and change detection capability. We want to make sure we design the whole system that we can capture the environment changes. And as the self-driving car use a map in its mission, we can constantly capture the changes and use these changes to update the map as soon as the car detects the change.
How does that work in practice? So you're relying on your customers' data for the map originally, and it sounds like for the map updates, rather than sending your own vehicles out really for that. So how do you get the changes back from the vehicles? How often does that happen? And how much updating is there?
So first we build a map, either using our rig or using our customer's vehicle, maybe remote controlled or driven by a driver, right? Then we collect the raw data and then we make a HD map out of it. Then the customer car will have a copy of the data on the map on it, or they can use our map through API. Once the car is driving, it will detect changes on the road because a car has a perception system. It has its sensors collecting data, a huge amount of data. And then we can use this data to find out changes in the environment. And we can keep the changes and propagate the change back into the map. Of course, there's certain pipeline to make sure the changes are real and the changes are correct. So there's a certain QA process in this as well.
Talk about where the HD map sits in the autonomous stack. We hear about SLAM, simultaneous localization and mapping. Can you explain what that is and where mapping sits in the autonomous stack to integrate with an autonomous driving system?
Yeah, SLAM is a basic robotic capability, right? When you have a robot in an environment, it need to understand what is around it, right? It need to understand where are the obstacles. So this is the mapping part. And the localization part is once you understand the environment, you need to precisely know where you are located in this environment, which lane you are in, and how far away you are from the stop line, for example, right? This is a localization part. So simultaneously, localization and mapping is, in certain sense, a basic capability for any robot. And but the mapping part is only for an individual robot to observe an environment that the robot is in. And what we are doing is for this each of this individual robot, when they observe the environment, we do the fusion and we do the dispatch and update to the self-driving cars. So that for a self-driving car, if there's one car in a certain region that it has observed the environment, it did the mapping part, then this information can be shared to all the other vehicles that need to traverse into this region or deployed in this region as well. So it's kind of a shared environment knowledge. And when the car is constantly moving around in this environment, it will capture the changes and update its memory. So that's what we're doing.
So when an autonomous vehicle is driving down the road, how do they use the HD map? We know about the autonomous stack. There's sort of perception and prediction, planning and control. Where does the HD map sit in that stack? Does the car compare what it's perceiving in the world to the prior existing map that you've given them and then go from there?
Yeah. So it's a great question. Mapping is HD map is a foundation of the self-driving car stack, and in certain sense, it's also connect a lot of the components of the self-driving car stack. So, for example, the first thing you need to for a self-driving car to do is to localize it itself. It need to understand where it is inside the map and in the real world. But that's the first usage, I will say, the basic usage of the map. You need to understand where you are. And once you know where you are, you need to do perception, understand what's around you and what is not in the map, what is actually the map, and what are the regulations, speed limit. This is kind of the perception and planning part associated with the map. If you don't know where you are, if you don't know the speed limit, you cannot do planning. Right? And also there's the other part is routing part. You need to figure out what are the paths you're going to take, what's the route you're going to take to go from one place to the other place at a centimeter level precision. That's also very, very important. You need to build a horizon where can tell the self-driving cars what's going to happen and how it will be moving. And also the map will give it's almost like a super sensor to the car. Even if there's obstacles, like maybe a truck blocking you view to the traffic light, you can still know where the traffic light is. Or maybe there's a turn. You can see through the corner, but with the map, you can still understand after the corner, after the turn, there's two lanes become one lane or one lane become two lane, right? So it's almost like a super sensor. This is all this part. And also you mentioned like the map is also helping to check against the perception system, right? If your perception system see a traffic light or a sign, it can check against its memory, which is a map, to see if it matches.
Yeah, and it seems like mapping is a form of pre-computation by doing the perception and localization of at least the static objects. There's sort of a baseline to compare to, but also there's less work to do and the car can focus on things that are changing.
Yeah, it's more than that. If you think about this, the map is not only a pre-compute shared memory of the self-driving car system, it is also critical for simulation. So you need to have the simulation running in the map environment maybe millions of times before you actually can deploy your self-driving car system safely on the real world. So it's critical for simulation as well. Yeah.
So the map lives on the car and doesn't require any connectivity?
It actually, we could put a very big cache on the car, and for any single self-driving vehicle, it has a region that range limit for where the car can be used, deployed within a certain period of time, right? So this make it possible to cache a lot of data on the car.
I see. So the operational design domain and geography of where you're actually going to test the car in that time period allows you to preload a map that's smaller than, it's not all maps, it's just the map you need.
Exactly. So this is similar to your mobile phone's map, right? You don't need to download the whole map on your mobile phone. But before you go to the region, and the route is already cached in your phone, and the region nearby probably already cached there as well. We can do a lot of smart things there to manage the footprint of storage on the self-driving car, and also we can be very smart to update it as the position of the car or the mission of the car changes. On the other hand, there's certain critical informations about the environment change should be propagated back to the server or from the server to the car as well. So we would need some connectivity, but it's not required to have always a connectivity between the self-driving car with the map center or a map backend.
So we hear a lot about autonomous vehicles having these big computers in the trunk and also generating huge amounts of data themselves. What is the compute power then needed to run an HD map? And what are the data needs for sort of the map itself?
That's a very good question. So for self-driving car, it needs a lot of computation power on the edge, which is on the car, right? Mm-hmm. Also, there's a lot of data collected because of the number of sensors on the car. So both the amount of data and the computation and also power consumption as well is very high for the self-driving car. For mapping part, actually, a lot of the mapping calculation can be done offline. Some portion can be done on the car, and most of the computation can be done in the cloud.
So the processing occurs in the cloud more so than at the edge in the car itself as you're going. Is it just the small pieces of change that might be fed back more frequently and require some sort of processing at the time?
Yes, that's exactly the idea. You don't need to upload all the data in the environment to the cloud. You can only upload the changes and new changes. We actually can do a lot of smart things on the edge as well. However, for map making, map update, it is not like the perception and controlling system of a self-driving car, which has to be real time, which means milliseconds or even faster than in a few milliseconds. The car has to make a decision, has to quickly understand the environment. So these components are critical. For map update and changing, we don't need that high frequency to find out the changes and make a map, update the map, because it's a prior knowledge. However, for certain functionalities that is tightly associated with mapping, for example, localization, you need to get it as fast as possible. Because if the car took 2 seconds to understand where it is inside the map, It has no time. It's too late. Right? It's too late
Yeah.
to control the car to do anything. It could run into a different lane. It can be super dangerous.
Right.
This is also we have to be very efficient in the data structure and how we organize the data so that the car can quickly do planning and routing and this kind of map-related operation.
How do you think about mapping as a portion of the total cost of AVs? I would think that using something like DeepMap would be a cost that can be shared across a number of customers, but are the costs of mapping coming down? Are there technical breakthroughs that are needed in terms of either sensors or compute or processing to improve HD maps or to change the cost structure?
That's a great question. That's exactly why I started DeepMap. As an engineer, I live a fairly, very, very good life in the Valley. There's a lot of job opportunity for me. But I clearly see there's a huge need for a solution for HD map because it's kind of too expensive to be used, right? In certain sense. That's why we start DeepMap. We try to reduce the cost of HD map making and maintenance, make this affordable for any self-driving car players, and minimize their spending on this technology and avoid their reinvent wheels along the way. If you look at a few early self-driving car companies, they all did their HD map in-house. And there's a very good reason for that. Because HD map, as I mentioned, it's tightly integrated with the self-driving car's sensor, computing capability, and other software modules. So in certain sense, if you think a self-driving car has a brain, the map part is actually a portion of the brain. It's almost like a memory of the brain, right?
Yeah.
So it has to work with all the other sensors and how the brain understands the environment. So this means it is difficult to use a standard mapping database for different self-driving brains.
I was going to ask that because on one hand, it seems like you're trying to centralize the mapping function so that you can spread the cost among multiple customers. So
Yes.
It seems like you would just create the map and let everybody use it, but instead you're creating separate maps for each customer, which seems like greater cost and friction in terms of having to get the different data. If everybody's driving in Palo Alto, like why can't you just have one map for Palo Alto? And so that's really the question that I had is you're gaining some efficiencies by having your common map engine, but not more efficiencies by doing just one map. And is that because the customers' autonomous stacks differ, their sensors differ? What is it that is unique about these different autonomous drive systems?
That's exactly right. So the problem with self-driving car space is, first, there's a lot of different applications. There's trucking, there's urban robotaxi, there's level 2 plus consumer vehicle self-driving ADAS system. There's also last mile delivery, sidewalk robots. It's all different. And even, let's just say, look at the ADAS system, which actually has much less variety compared with the other pieces because it's fairly mature, in my opinion, like ADAS system level 2 plus. But even if you look at that segment, the sensors and technical stack are quite different from different OEMs, different self-driving car solution suppliers. Some might use radar heavily, some might use camera heavily, right? Onboard computing system are different. There's quite some difference there. The core problem is we don't have a standard for self-driving car stack. So that means we don't have a standard for the brain and the sensors and the eyes and sensors. And if that's difficult to standardize or take a while to standardize, The map portion, the memory portion will take an even longer time to standardize. And in the early days of self-driving car development, there's a lot of customization needs so that the map can be fit into the self-driving car stack, fit into the sensor specs.
So is it like an integration problem? Because I'm thinking, well, why does it matter which sensors, or if somebody's using one type of LiDAR versus another type of LiDAR, like why does that matter from the map? Like the street still looks the same. How are you integrating into the brain or the autonomous drive system, and why does that matter?
So if you were talking about strictly digital clone of the environment, it's actually quite similar, right? We tried different type of LiDAR sensors, multiple LiDAR sensors. The 3D reconstruction of the environment is fairly similar. But however, if you look at the details, they're still different. Even with LiDARs, the reflection are different. The view angle of the LiDAR will be different, right? The precision of the different LiDAR system will be different. And this will end up with slightly different replication of the world. And even if we only talk about LiDAR. But there's other sensors. If you have radar or 3D imaging radar, what the radar observes the world will be quite different from the LiDAR. And there's also camera. And for the camera, and it's not only just the image anymore, there's perception output. Different perception output will have different meanings, and they will capture different features. The precision, the perception system will also change, varies. So again, it's a little bit early to even at the data level, at the data representation level, to have like, okay, one map that actually covers all the different sensors. We have to add a lot of different customer layers, but it's more than that. The map, if you look at the semantic map, we have to do a lot of customizations depending on how the self-driving car, how our users are using the map. Some use the map to control the vehicle, right? Some use the map, they need the map to be in a specific format or provide specific features inside the map that satisfy their need. For example, a very simple example for robotaxi applications, there might be nothing in the physical world, right? But in the map, there's places a self-driving car can park and pick up passengers. Very simple example like that, right?
Right.
So there's a lot of customization needed still. So everybody, what they need, what the customer really need is the map making capability and map updating capability. They don't really need the data. Think about the self-driving cars traverse the segment of the streets multiple times a day. They collect tons of data already. They've got the data.
So the one thing that would bring the cost of the mapping down would be in the future if the autonomous vehicle industry standardizes around a standard stack or standard sensors or something like that, where the map would be the same for all the vehicles. That would make it less bespoke.
That's one ultimate goal. That's an ideal situation. But we don't believe that will happen anytime soon. Because if you look the self-driving car applications, it varies a lot, has all kind of different needs. We serve a lot of customers in 8 countries, right? We did so many projects all over the place. And it covers trucking, robotaxi, level 2, 2+, ADAS system, delivery robots, all these applications, indoor mapping. It's all different. And they have different needs. And even a lot of them, they don't even have overlap. So there's like sidewalk robot, they care a lot about sidewalk maps. And there's like a robotaxi, they don't care too much about that. They only care about the road surface and the obstacles, right? And for
Right.
highway trucking, they only care about the highway segment between hub to hub self-driving trucking system.
Right.
So I think, and also, again, another thing is the regulation in different part of the world are different for self-driving cars and just for normal driving, right? The traffic system, the regulation system from one country to the other are different. The UK drives on the left, for example, right? I mean, this is very simple to understand. Once we get into this business, it's fascinating to see how much difference all over the place. Inside a campus, right? For example, a self-driving car system can be quite different for a public street. You have to care a lot about different things. So to us, we believe it would take a long time to get to the self-driving car stack standardized, and everybody use the same map, the same sensor. It's almost never going to happen, in my opinion, because of the variety of applications of self-driving car system.
Right. So you're selling to all different types of customers, both the different types of autonomy use cases, as you've mentioned, as well as sort of OEMs and tier ones as well?
Yes, we sell to all kind of customers, retailers and the delivery companies, logistic companies, trucking companies, OEMs, tier ones, tech companies, startups, all kind of customers. We learn so much by serving all these different customers. It's very fascinating for us to see how much money we can save for them and how much time we can save for them, right? Without a company like DeepMap, what the customer can do usually is like either build their own map team and create their own map, which takes a long time and has a high risk as well because they could do it in the wrong way. Another thing is once they want to scale, like moving from one place to the other or scale the site, doing a larger scale of testing or change the spec dramatically, this will take a lot of their time and they can't easily scale. What we learned by serving all these our customers, they can save a lot of money, reinvent wheels doing the map part. They can actually hire us within days. We can actually make the map ready for them anywhere on this planet, right? We have this portable rig. We can ship it over without our employees, just ship over, hire somebody local or use our customers' resource to do a local mapping. And sometimes even we don't even need to ship our rig. We just ask our customer to upload their data to the cloud. We make the map, they download to their car and start using it.
So you're selling using a SaaS model, your map engine as a service?
Yes, that's for the robot taxi and level 4 system, we're shooting for that. However, the world is changing. There's something new called L2 plus or L2 plus plus ADAS system, which is a more advanced system than the level 2 system. And for that huge market, we also can help to make. So in that market, our business model will be a little bit different because if you look at the robot taxi or level 4, level 5 self-driving applications, they usually are quite different in the early stage of R&D and their spec are quite different. But if you look at the level 2 plus market, everybody need a giant map upfront that can work mostly with their car. And by the way, their car usually don't have a LiDAR on it.
Right.
They have a camera. They have much cheaper sensors, much lower computation power on the car. But it's okay because they have a human driver on it as well. Right.
So with ADAS, when you are selling maps to ADAS providers, are you updating those? I mean, there aren't that many companies that are doing regular updates over the cloud. So how does it work with ADAS?
For ADAS mapping, so from our perspective, there's no such thing like ADAS map versus the level 4, level 5 HD map. It should be all the same thing. It's just like a very high precision map, centimeter level precision, and have all the necessary features or landmarks that a self-driving car need. To us, it's the same problem. And to us, the level 4, level 5 HD map is a tougher problem to solve. And we already solved that. We built the engine that are able to create a very high precision map and update them for our numerous customers in that space. Now, what we can do is we use the same engine and look at the L2 and L2 plus market and use the technology advantage we developed through the last 4 years to minimize the cost of making a full-blown, very high precision 3D map that can serve slightly different requirement of different L2 plus or ADAS applications. Does that make sense to you?
You're saying that because you've already solved the harder problem of a map that a level 4 car can use to drive, that certainly it's good enough for level 2, plenty of specificity and that sort of thing. What about so I understand that from the original map perspective. What about updates? Are there updates to level 2 systems? How is that working?
That's a great question. For the update part, because in certain sense, if you look at the level 2 cars, their map making and map update capability is limited due to their limited sensor and computing power on the vehicle, and they don't have the LiDAR. However, they have a lot of observations, a lot of data, because they're huge volumes. And these kind of data can be harvested in map update.
On the edge?
On the cloud. On the edge, we collect candidates and we accumulate those fuses information on the cloud, and we use those information in the cloud. We do the QA and make sure actually the changes are real.
I see.
And periodically, we still need to update the map using better sensors. So for example, there's like a street completely changed, or they build a new street. If you send your level 2 plus car over there, drive through, you collect a lot of camera data, sensor data, radar data. Using that data to build a centimeter level high precision map is difficult. So you can have a good sense of the environment, but you don't know what we call ground truth, right? You can observe a lot of things, but you don't know the ground truth. So for a large region, this kind of major fundamental changes, what we call is the changes to the base map. Periodically, we need to send our rig over, the mapping rig over, to update the map. So we do two types of update: crowdsourced using consumer vehicles and our sensor rig based update as well.
So you're selling to autonomous vehicle companies of all flavors and types, and you're also addressing the ADAS market, which seems like it gives you a bigger market to sell into. Progress has been slower for the fully autonomous vehicle development than some people thought back in 2016. How do you see the future of autonomy and the industry developing over the next few years?
So it is slowing down a little bit than a lot of people's expectation. But from an engineer perspective, I think the industry is just normal. They're making the right progress. There's no magic to jump from one situation to the next stage. There's a lot of work need to be done. Just like what we have done in the last 4 years, we learned a lot. We dramatically increased our efficiency and the mapping speed. We also learned so much about all kind of mapping, local map regulations, drive patterns, and also map specs for all kind of different situations. I think this is true for us that it took time for us to build this map engine. It also takes time for the self-driving car players to develop their technology. This is a pretty challenging task. It's challenging in multiple perspectives. The first, cost is very high. We heard news like $1 billion raised for a lot of players, right? And there's company burning billions a single year just to develop self-driving car technology. The risk is also high, right? Any failure there could be very significant. So we strongly believe collaboration is the future for self-driving cars. We have to reduce the price of self-driving car system. Otherwise, it will not become a product, right? So, for example, the LiDAR industry, if you look at the LiDAR industry, we see a dramatic drop of LiDAR price in the last 4 years, almost 50% every single year. And there's a lot of players, hundreds of companies developing new, cheap, affordable LiDAR technology, LiDAR sensors for the self-driving car system. We are actually doing similar things. We're building this engine. We're making the HD map making an update as cheap as possible. And the self-driving car industry need a lot of this kind of players, chip makers, perception companies, even remote control companies, prediction companies, right? Simulation companies, integration companies. There's so many pieces in this self-driving car stack. But if we have the best team, best expert working on this specific field, when the ultimate player of self-driving car integrate these pieces, the system will be affordable product. Because eventually we're competing with human driver, right? And normal car. You have to build a product that is safer than a human driver and cheaper than a human driver and a normal car. It is not easy to beat that, to make this into a product, right?
Right.
Yeah, so we strongly believe in collaboration, and it's very clear that's a right trend. 4 years ago, before we started the company, if you talk to any self-driving car players, they're pretty much building their own maps. But today, if there's any new self-driving car companies, a lot of them will try to buy over the counter, right? So, who can make maps for me, right? Outsource this. Why should I spend tens of millions doing this myself? And I don't even know I can make it right or timely. There's a competition globally for who can build a self-driving car product first and deploy it, right? This is the main thing, main challenge, I believe, is we need to be open and collaborate with all the players in this industry to make self-driving car a commodity, a reality sooner. And there's no way to stop this anyway. If you look at the ADAS system, level 2+ system, right? There's a computer inside the car driving it anyway, although you have a human driver, right? There's a computer in it driving it. There's sensors. They have better and better sensors in it. Volvo just announced they're going to have Luminar LiDAR in their 2022 cars.
Yeah.
Right. So, I mean, that's huge. And this is not alone. There's Innovate's announcement, a Valentine agreement with plenty of other OEMs. There will be a lot of cars with more sensors and better sensors. And Tesla's building chips for the cars as well. Mobileye is building chips for the cars. NVIDIA is building chips for the cars. The car will become a moving computer with more and more sensors on it. There's nothing can stop that trend.
Right. So we're recording this in May of 2020, in the middle of what has been a pretty devastating global pandemic. It's paused a lot of development in the transportation space. We've been in a bit of a trough of disillusionment in the autonomous vehicle industry as the pace has slowed over the last few years. What do you see as the impact of the global pandemic on the autonomous vehicle industry going forward?
That's a great question. I mean, the pandemic definitely slowed down a lot of things. But for the self-driving car space, my humble opinion is actually it's just accelerated the bubble burst, the hype of self-driving car technology because of the pandemic. So I think any bubble burst or anything bring the industry to the ground truths to the ground, right? It's a good thing, right? It's a good thing because we'll have the resource allocated to the right players and to do the right thing. That's kind of my opinion. So I'm pretty optimistic about the pandemic's impact for the self-driving car industry. Right. On the other hand, the pandemic actually raised a very good point. So, before the pandemic, there's a lot of discussion about how dangerous AI could be, right? But actually during the pandemic, I think it's very clear to everybody that human being can be dangerous.
Yeah.
We cause a lot of trouble if we're part of the transportation system, if we are the taxi driver, if we are the delivery guys, if we are doing the shopping, right? And when there's a pandemic, it is dangerous. I think this actually will create a bigger need or a push from the global market to develop and deploy self-driving car technology, autonomous vehicle technology sooner to the market. Because it's not just to replace human. It's not just an economic thing anymore.
Yeah.
It's also a safety issue as well, scalability issue as well.
Yeah.
So I think this is a kind of a wake-up call for the industry.
What does the next year or so look like for DeepMap as a company? You've raised some money. Is it about 90 million? Who are some of your investors? Are you planning to raise again in the short term or grow, add employees? What does the next year look like? Our
biggest investor is Andreessen Horowitz. We also have Excel, Generation, and Bosch, NVIDIA as well, a bunch of investors. We have enough funding for several years. We actually solving a very difficult problem. Think about this. We're building not just one map, not just one spec. We're building an engine that can plug into a lot of different self-driving car systems. And we're trying to make this as cheap as possible, as efficient as possible. And we need to make this engine to support tens of thousands, millions of cars in a few years scenario when you have a lot of consumer vehicles with LiDARs or delivery vehicles with advanced sensors on it. So we're not there yet, but we're still trying very hard to make our map dirty cheap, our service dirty cheap, so that the self-driving car can be affordable and deployable sooner. In the next year, it's hard to say how bad the pandemic situation will be, but we believe it will over within a year for sure. Mm-hmm. And we have a much longer runway than that. And we will develop our business with our partners in all level of self-driving car systems, from level 2 to level 5. We don't really care what the customer's system is. We just focus on providing the best solution on the mapping part, has the highest quality, and also we can maintain it. We're also doing this in a global sense. We're doing this business in Europe, in Asia, in US, of course, all over the place. We try to enable our customers to get their product onto the market sooner.
Well, terrific. Exciting times ahead for DeepMap. Well, thanks so much for coming on the podcast. It was really great to hear about what you guys are doing.
Thank you for inviting me. I'm an engineer all my life, and I was fascinated by mapping when I first graduated with my PhD. And I worked for 6 map companies now, and I'm fascinated by the self-driving technology. This thing really will change the world for better, for sure. And as an engineer and entrepreneur, I welcome anybody to reach out to me to discuss their map needs or their questions about the maps, or just talk about the self-driving in general, the future of AI. My email address is jameswu@deepmap.ai. It's very easy to remember. I welcome any discussions and would love to answer questions if there's any.
Great. Well, we'll put links to your website and contact info in the show notes and encourage everyone to reach out.
Thank you so much.
Thanks for coming on the show. Thanks again to James for joining us. You can find the show notes for this episode and all of our Season 5 episodes on our new publication at smartercars.substack.com. If you're enjoying the show, please leave us a rating or review at Apple Podcasts or wherever you listen to your podcasts. Thanks again for listening. We'll see you next time.